Okay, so first example. Well, there's nothing multiplied to the sign, and we're not adding anything to the sign. So this is just the basic sine function shifted, and it's going to have a different period because the number multiplied to the domain variable is not 1. All right, so if you want to make a unit circle map, you can, but this is probably something that you're more familiar with. You don't really need the unit circle map. Since the sines are the y's, if you want to do that, if that's helpful, you can go ahead and do that. All right, I'm going to factor out the 3. All right, so in other words, this represents a horizontal shift to the left by pi over 3. What you're basically doing is you're finding out when does this start. Normally, it would start when x is 0. But if x is 0, we get 3 plus pi. The sine of 3 plus pi is not the same as the sine of 0. So the phase shift basically is putting the domain expression equal to 0. So you could solve that problem. You could do that. Subtract pi divided by 3. But if you factor out the 3, it's a lot easier to see it's negative pi over 3. That's why that's a good idea. So the phase shift is negative pi over 3. Now what's the period? The period's based upon the number multiplied to the variable, which is 3. And again, this would have happened before we had the horizontal shift. So this would have been 3x. And then when we made the horizontal shift, that's what we would have substituted here. Another way to think about it. So the 3 is relevant only to get the period. Okay, so the period, divide 2 pi by 3. Now here is where quarters are a good idea, because you got these gnarly fractions. Granted, they're both denominators of 3, that's true. But as you go around each quarter of the cycle, what are you going to add to get the other intervals? We know we're going to start at negative pi over 3. What do you add to that to get the next one, the next one, the next one, and then the fourth one will be the end of one period? That's what I call quarters. And if you multiply this by 4, that'll give you a quarter of the cycle, the intervals that you're going to use for the x-axis. Okay, so that's what? 2 pi over 12, which is pi over 6. Okay. All right, so now what I'm going to do is I'm going to start at negative pi over 3, which is the same thing as negative 2 pi over 6. 1 quarter later, we're going to be at pi over 6. Another quarter later, we'll be at 2 pi over 6, which is pi over 3. Another quarter later, we'll be at 3 pi over 6, which is pi over 2. Again, I'm doing the simplification in my head. And then we finally end, which is going to be the end of one period. Oh, wait, I just realized I made a mistake. This should be negative pi over 6. Okay, I caught my own mistake. So when you add pi over 6, that stays negative. All right, and then this is 0, and then pi over 6, and then 2 pi over 6, which is the same as pi over 3. Okay, so that means here's the y-axis. We already had the 1 and the negative 1. Okay, so we start here, 0, and then 1, and then 0, and then 1, and then 0. All right, now in this case, I put the x-axis intervals first. You still don't have to do that. You could have just made this graph and then put the x interval numbers here. The thing is it's a good idea to know where the y-axis is. Okay, notice I'm not putting coordinates as a coordinate pair. Now, the x-axis intervals and the y-axis intervals are good enough. Right? You don't want to get in the habit of doing this all the time. Because you can already tell by looking at the x-axis intervals that's unnecessary. Okay, and it actually doesn't help you if you rely on that. Okay, so the next one. The next one would be that. And notice now we have a negative period, and we also have a negative amplitude. Right, so y equals -2 sine, and then -2x plus pi over 2. All right, so again, we're not adding anything to this. So it's going to be -2 times 1, -2 times -1. All right. So because we're multiplying by negative, now it's going to be negative above and positive below. And so here's where 2 is, that's where -2 is, and that's where 0 is. The negative period means as we go to the right, this is going to become negative times a number, which means the angle in the function is actually going in that direction. All right. So now I'm going to factor out a -2. And I'm writing it that way so you can see why that becomes 4. Okay, so our phase shift, which basically means when does this equal 0? So you can solve the original expression and equal to 0 if you want. Okay, it's just if you can do the factoring out, it's a lot easier to see, okay, pi over 4. So that's the phase shift. That's when we're going to start the graph. We're going to start right here. The x is going to be pi over 4. The next quarter, we're going to go up to 2. The next quarter, we're going to go down to 0. The next quarter, -2. The last quarter, back to 0, and we repeat. Now, the -2 just means going in the clockwise negative rotation direction. To get the period, we just use the 2. All right, so 2 pi divided by 2, so pi. Okay, so then quarters would be 1/4 of pi. Okay. All right, so we're going to start here at pi over 4. 1/4 later would be 2 pi over 4, which is pi over 2. Another quarter later would be 3 pi over 4. Another quarter later would be 4 pi over 4, which is pi. And then at the end of the cycle, 5 pi over 4. So notice instead of starting at 0, we started pi over 4. 1 pi later is the end of the cycle, the period. All right, and if we went back by pi over 4, we'd land at 0. So here's the y-axis. All right, so we're starting right here. 0, 2, 0, -2, and then back to 0. And then if we wanted to go in the reverse direction, which would be that way, then we'll go from 0 to -2, and then we could continue if we wanted to along those lines.
Mr. Napoli,
If it's a net,
oh, sorry, good.
What did I do?
wouldn't it be reversed since it's a -2 amplitude?
Well, right. So if you're going to the left, notice I'm going down to -2. As you go to the right, because of the negative period, when you replace x's with positive numbers, this becomes a negative angle. So as we replace x with positive numbers, as we go to the right, we're getting a negative angle. So we're doing this way. Now that's 2 because we multiplied by -2. So these two had to change signs because of the multiplying by -2. As we go to the right, we're substituting positive numbers for x. which multiplies to the -2. And so the sign is actually a sign of a negative angle, which means we're actually going this way as we go to the right. When we go to the left, we're going to eventually be placing x's with negative numbers, which is going to make this a positive. So the sign of a positive means sign as you go into the positive rotations. I'm not sure if that clears up what you were discussing. Is that all right?
Yeah, thank you.
Okay, you're welcome. All right, so we got one more. Okay, and that's this one. Now we're going to have a vertical displacement. Using the unit circle can kind of be helpful, although, not all the time it's necessary. Like maybe the second one, you would have been all right without a unit circle map. But it can be helpful to kind of simplify what you're doing and not become overwhelmed with all of these numbers, because that is a reality. Humans, we're not born to do numbers. We have to be trained to do numbers. So numbers can overwhelm us. That's why we have a hard time understanding big numbers. Humans, it's one part of the reasons why. Can you imagine $1 billion? No, it's too big. I think a stack of $1 billion is something like 3 miles high. I remember looking at it mathematically. Don't quote me on that, but it would blow your mind if you actually saw a visual. Anyway, that's neither here nor there. So we got a vertical displacement. So we're going to drop down to y equals -3. And the amplitude means 2 above, 2 below. You could think of it that way. So we're going to have 2 above -3, 2 below -3. You could think of it that way. Another way you could think about it. Okay, so normally this would be 0 for the cosine, 2 times 0 minus 3. Oh, I'm bad, stupid. Normally that'll be 1 for the cosine, right? So 2 times 1 minus 3. Here, 2 times 0 minus 3. Same thing here. And then over here, it's -1. 2 times -1 minus 3. Okay, so we're going this way. And maybe that's another way for you to be successful with this. Okay, so I'm going to factor out the 2 pi. And we get that. All right, so the phase shift. Again, what we're really doing is we're putting the domain expression equal to 0. When does this become the cosine of 0? That's when we start. So you could solve that equation, subtract 4, divide by 2 pi. If you factor out, notice you can see this is -4 over 2 pi. Which I'm going to simplify into -2 over pi. All right, and this is where quarters are very helpful, because this is an irrational number, which means it's going to have to be estimated. And you don't want to get in the habit of estimating. So we're going to use this as a quantity when we eventually get down to creating the x-axis intervals. Okay, now the period. Well, 2 pi is the number multiplied to the domain variable. So the period would be 2 pi divided by whatever that is, which in this case is also 2 pi, so 1. All right, so from x0 to x1 is 1 period. A quarter of that would be 1/4. Okay, let me put that up here so I have a little more room. All right, so here's our x-axis, and I'll just go ahead and put the intervals there. All right, so we're starting at -2 pi to 2 over pi, and then we're going to add 1/4 to get the next one. Now maybe you want to get a common denominator and simplify that, but I'm going to leave it like that. Okay, and then the next one you add another 1/4, which would be 1/2. And then you add another 1/4, which would be 3 over 4. And then you add another 1/4, and that would be 1. Notice the last one is adding the period to the starting value. All right, well, this is roughly a little less than 2/3, right? Because pi is bigger than 3. All right, so if we add 1/2 to that, it stays negative. So the y-axis is somewhere right around here. All right, now we can go ahead and continue. -1, and then -3, and then -5. And I'll go ahead and put the center line to make this a little more visual. Okay, so -1, -3 on the center line, -5, 2 below the center line, -3 on the center line. Oops, put that in the wrong spot. That's right here, not on the y-axis. And then last quarter, and so then this would be, oops, I should have put that on the x-axis. That's -1. And we have the x-axis intervals represented with exact values. Now, again, if you wanted to get a common denominator, right, you could do that, but it's not necessary.